Good afternoon. It is time to start the webinar. It's a best practices webinar. We've been doing these for the last year or so. We've been doing webinars for the last couple of years, but focusing in on the best practices guidelines that NAFA publishes. This one is filtration for the residential HVAC industry. Thanks for joining us here. In just a second, I will introduce Kevin, but just wanted to let the room fill up here. This one's great because we've done guidelines for schools. We have one for indoor cannabis growing, which we'll be doing at some point. We've done ones for libraries and commercial office buildings and continuing care, but not everybody works in in one of those facilities, but I suspect everyone here lives in either an apartment building or in a residential single family house as well. I did actually reference apartment buildings, but I think Kevin, actually I misspoke there. I think that when you talk about residential
low rise.
Yeah, low rise. Yeah. Anything
Yeah.
high rise is more of like a commercial building. So I probably shouldn't reference that. Anyway, so looks like we should get started here. We're just about a minute in, and so got a few people joining here. But we'll go ahead and read your bio, and I'll hand it over to. Then I'll have a couple slides here for NAFA, and then I'll hand it over to you. Okay. All right, give me 1 second. Okay, so again, welcome everyone. My name is Tony Verhoeven. I am an associate director for the National Air Filtration Association. This is a review of the NAFA best practices for the especially filtration for the residential HVAC area here. So Kevin Delahunt is our guest today, our speaker today. Kevin's spoken on this topic and similar guidelines because he is the lead author on several of these here. So Kevin Delahunt is a certified air filter specialist, the senior technical advisor with BG Indoor Air Quality Solutions. And Kevin's been active in the filtration and IAQ industry for over 40 years. He's a CAFS. He's a NAFA certified technician from NAFA. He is the life member of ASHRAE and the Building Operators Association of Canada. He has served on the board of directors of both NAFA and BOA. He is currently the chair of the NAFA Guidelines Committee and the lead author of several guidelines, including this one, and the commercial office buildings, and contributed to several others, I would imagine, right, Kevin?
Most of them, yeah.
Kevin, yeah, there you go. Kevin continues to serve his passion for the industry by delivering numerous educational and training presentations to BGE employees, educational institutes, industry partners, and facility operational personnel. I know, Kevin, you people can usually catch you at the AHR Expo. You'll usually have a session there. And so we appreciate that. So people probably have heard of you before. So with that,
I have an exciting one coming up in January at AHR. So
excellent.
I'm not going to say any more.
Oh, okay. And AHR this year is in Chicago.
Chicago, yeah.
Oh, yeah. Okay.
In January.
Yeah. Excellent.
Yeah.
Okay. This webinar is put on by NAFA, and NAFA is a membership organization, but we're also specialized in education and expertise in filtration as well. So if you are in the air filter business or the kind of the extraneous area around there or in the periphery, you should be part of this organization. We've got a couple member quotes here. If you want to compete in the air filtration business, you need to be part of NAFA. And so that is, dues will pay for themselves just by being part of the organization. So let's go ahead. One more, Kevin, there.
Mm-hmm.
Speaking of best practice guidelines, this is the flyer that we actually we'll bring to Filt Expo. We'll be at Filt Expo in Chicago on Navy Pier in October. And then again at AHR, you'll find this at our booth and several of our members. And these are the best practice guidelines. So the guidelines, just real quick, are basically, application-based guidelines on ASHRAE standards. So ASHRAE standards, denote a minimum standard, and then these are the guidelines on which those are built. So that's what Kevin's going to talk about today with those guidelines for residential HVAC. These are completely free. You can hover over these. You can go to our website, download them from there if you'd like. No problem. Okay, so yep, go ahead. And then finally, and we'll remind you at the end, is please stay online for at the end when I close the webinar, a SurveyMonkey survey will pop up. Please take our feedback or give us feedback. We really appreciate it. We do look at that. We do share it with our education and training committee. We want to know what other webinars that you want to see. We want to know how the content is, and make sure we are staying abreast of everything you want to learn. So with that, Kevin, I will hand it over to you.
Okay. Do you want to make?
Oh, one more. There's one more slide. Yes.
Yeah.
So in 2 weeks, we will be in Nashville, September 13th through the 15th. And we're really looking forward to that. We've got 200 air filtration professionals signed up and counting. So we look forward to seeing you at the Lowe's Vanderbilt hotel there. So take a look at NAFAHQ.org for the annual convention. And one more thing, we do have another annual event that's usually in April, and that's called the NAFA Technical Seminar. So read more about that on our website. Okay. I think one more is the follow us slide. There will be a copy of the slides. Yes. So we'll download those or let you download those. We'll send you a link to this webinar so that you can watch this again or share it with someone that you think should see this. Okay. Now I think that's the last one.
That is the last one.
All
but
right.
I have one question in regards to the cannabis guideline. Are there free samples available for
Check local listings, right? You're in Canada. You're in Canada.
Okay. Yeah, it's illegal here. So yeah.
Yes.
Well, thanks everybody for joining me today to talk about the residential guideline. Just a little bit about BGE, because they do pay my salary when I am working and not in retirement mode. Western Canadian company with 7 branches across Western Canada, Vancouver, right to Manitoba, Ontario border. We manufacture in Edmonton and 200 plus employees, and we are proud supporters of NAFA for, I'm going to say, more than 30 years anyway. So with 16 NAFA CAFSs and 18 NAFA or NADCA certified technicians, NCT and ASCS. So to move on here, we got some great questions that came in, and I thank those who submitted questions early, because hopefully I'm going to answer some of those questions as we go through the material, but in some cases we'll answer them at the end here when I'm through with the presentation. NAFA's mission statement: to be the global source for expertise, education, and best practices in air filtration. Again, the Guidelines Committee is really focused on that best practices in air filtration. So we're always looking for, ideas to try to provide some best practice guidelines for areas that aren't covered by many other organizations. And we definitely get more in depth on filtration than you'll see in other organizations. So again, the best practice guideline, filtration for residential HVAC industry. So we try to direct this one, not specifically for technicians, but anyone that, has, a unit or a system at home and has questions on the air filtration and indoor air quality issues that surround that. So as with all best practice guidelines, we have a purpose, and the purpose is to establish air filtration for removal of particulate and gaseous contaminants for the protection of HVAC equipment and components, as well as providing comfort and a healthy environment for the occupants and visitors of a residential property. Okay. This is one of the newer guidelines. We just published it in 2022. So if you haven't been on the website recently, you might not have seen this, but this is the first time we're doing a presentation on it as well. It offers guidance that is different than what the industry is hearing. So as I alluded to a few minutes ago, we're going to say some things that you're not hearing from, other organizations and standard bodies that I think needs to come and should be coming from the filtration industry. So we're really happy to have this out there. And as a working document, we're always open to suggestions, comments, edits, and improvements. So the other thing I'm going to ask for, I'm not an expert in the residential market. I spent most of my time in the commercial and industrial. So even having, I'm going to reach out to everybody here. If you have pictures and good pictures that would be complement this presentation, I'd really like to see them. And my contact information will be at the end of the webinar, or you can contact me through BGE as well. Some of the key highlights we have in this is that MERV 11 or better is our standard recommendation. We're starting at MERV 11, and we'd like to see even a higher number going forward as systems start to evolve. We broke the guideline into really two sections. One, we looked at system approach. So we looked at all the various types of systems that you would find in a residential facility. And again, MERV 11 or better. And then we also looked at additional air cleaning device options that are prevalent in the industry today, which I'll get in a little more detail as we go forward here. As mentioned, the recommendations of this guideline are considered by NAFA to be best practice as opposed to minimum standards proposed by other organizations. And the whole idea is to help service technicians, manufacturers, contractors, and homeowners with the necessary information to make an informed decision when procuring, installing, and maintaining filtration products for the residential market. We'd like them to consider filtration and indoor air quality as an important aspect of design, installing the units. And we don't think that is going on, especially in the past, but even today, and it needs to be taking a much more important role in the process. All right. In the scope of this, we'll address filtration products, installation, and maintenance practice for the various air handling systems that are used in most residential properties. It will take into consideration health, comfort, equipment protection, tenant retention, and factors involved in the filtration decisions. And this guideline will focus on single, multifamily, and low-rise multifamily residences. As Tony had mentioned earlier too, we're not looking at high-rise apartment blocks. They're more in line or have more in common with a commercial guideline, and the commercial guideline is available on the website as a free download. So have a look at that one if you're interested in high-rise buildings. Now, indoor air quality, we often associate indoor air quality issues with commercial buildings, industrial, schools especially, even hospitals, that type of thing. But modern residential properties face many of the same issues that commercials do. And if you watch houses go up, and I like to cycle around Calgary a lot, and I see all the new housing developments go in, and I watch a house go up, and I see all these things happening that are a little bit different than the design and construction maybe 10, 20 years ago. Much tighter sealed envelopes. You see the Tyvek wrap, just almost saran wrapped around the building to try to eliminate any air coming in through the envelope. They're built energy conservation, so tighter windows, tighter doors, just tighter envelope. More using synthetic materials, what can off gas and provide indoor air quality issues inside. The increase in office and home equipment. Most homes now have an office or two offices in it with copiers and printers and computers. And as well, a lot of people have their own fitness equipment. And COVID was a big push for this, where you weren't going out to the gym and you weren't going to the office, so you provided or you created those spaces within your residential house or apartment. Cooking, scented products, cleaning products, pets, increased odor outdoor air pollution. Western Canada, I don't know how many days we've had with smoke issues, but it's probably been in the 30 to 40 days where you could barely go outdoors without having a mask on. So that is the air that we're bringing in to ventilate not only commercial spaces, but residential spaces as well. And one of the biggest issues that I see, and I talk about a lot, is that the population now is much more aware of indoor air quality, filtration, and they're asking much tougher questions when people are looking at a furnace or replacing a furnace or providing a higher level of filtration into their facility. Again, the knowledge level has increased, and it's the pandemic effect. They've been bombarded by MERV and PM 2.5 and acronyms that they hadn't even talked about in the past. So you're probably aware, you might be aware, you might not be aware, but the only mandatory reference to filtration for the residential market is ASHRAE Standard 62.2, ventilation for acceptable indoor air quality in residential buildings. And I'm going to read this because it's very pertinent to this talk. So a filter shall be provided with a filter with having a minimum efficiency reporting value, a MERV 6 or better when tested in accordance with ASHRAE Standard 52.2. MERV 6 is, how should I put it, is well below our MERV 11, obviously, and I'm going to show you some slides that will sort of put that into context, why a MERV 11 over a MERV 6. But a MERV 6, again, is just doesn't cut the performance level that we think is required to provide a healthy environment for residential property. And this is the ASHRAE standard. And if we look at MERV 6, it's really a product that, will help protect the equipment and a bit of system hygiene. And even at that is only marginally effective. We don't think it's good enough at all. So, and if we look at on the right-hand side, you see some of the filters. These are MERV 6 filters, or relatively speaking, a MERV 6 filter. A lot of point-of-sale filters, very porous fiberglass. You have metal washable, and then a stamped synthetic on the bottom right. But if you look at a MERV 6 at the bottom of this chart, it really addresses a really large particulate pet dander, pollen, lint, dust, that type of thing. It's really not effective on the particulate that we're trying to stop. And that, again, is at least the PM 2.5, in that PM 2.5 range. So this is the chart I was talking about. If we look at this one, you get a MERV 6 filter, MERV 11, a MERV 13, and a HEPA filter. So if you look up in the upper left-hand corner, MERV 6 filter is less than 20% capture. In real terms, like we talk a lot about efficiency of filters, the MERV, what's the MERV, what's the MERV? What we really need to understand is that, and worry about and be conscious of, is what's penetrating that filter. So a MERV 6, if I had 5 million PM 2.5 size particles go through, you're going to have 4,250,000 PM 2.5 size particles. So we're really not capturing a whole heck of a lot. So if we're going from MERV 6 to MERV 11, we've reduced that penetration from 4,250,000 to 1,750,000. So just by going from a MERV 6 to 11, we've had a 250% improvement in the penetration, or 2.5 times improvement. And we go from a MERV 6 to a MERV 13, it goes to 565%, or 5.5 times improvement. And a HEPA filter is 2,800 times more efficient and 28 times the reduction in particulate load. So again, when we look at these, and I present this chart to a lot of people, I just ask them, which filter would you rather have in your space? The MERV 6 that's barely stopping anything, or a MERV 11 at least, or a MERV 13. So, and usually with this, you can at least visualize that penetration into the space. PM 2.5, I talked about this. Hopefully you understand what that is. Particulate matter 2.5 microns and smaller. How small is that? Well, I usually like to say, if you're drinking coffee right now and you got a packet of sugar, and you pour the sugar on the table and take one of the grains of sugar out there, get a really, really sharp knife and cut it into about 40 pieces. That 1/40th of that piece of sugar is about a PM 2.5 size micron particle. Extremely small, well below your site threshold, but the ones that cause most issues with breathing disorders and health issues. The challenge that we face all the time in the filtration industry is that it's not just taking a MERV 11 filter or removing the MERV 6 filter and sliding the MERV 11 filter into the existing hardware. As you go or increase in efficiency, the hardware that the filter sits in becomes more and more important in the whole sealing mechanisms. So it's not just the filter, it's also the hardware, and we have to think along system performance being the two, not just the filter performance. And to optimize that system, here's, as Tony said, I've been in the industry 40 years. The U channel on the left-hand side picture was there 40 years ago and might even have been there 40 years before I started, but it hasn't really changed. But when I started, I mean, you still had metal washable filters and light grade throwaway filters. And I'm going to show you another chart here where the effect on the performance is not that great on a MERV 6 or less filter. But once you start increasing the performance of the filter, a MERV 11, a MERV 13, a MERV 14, the importance of that seal becomes dramatically more important, as is the fit. So we got to start thinking along, these are commercial grade filter housings, very similar to even a HEPA housing for a HEPA filter, but they provide, you can see the U channel in there, but some sort of locking mechanism and a sealing mechanism to provide pressure to the filter so that all the air will go through that filter. And that is the goal of a filter bank and a filter system. If all the air goes through the filter, then you're matching that MERV to the system. If it's not, and again, I'll show you some examples of that. But also look at, are the filter frames clean? And it's a very telling sign when you look at a system and downstream of the filter, there's dust settled on the ductwork or the channel that the filter's sitting in. In this one, you see a 1-inch filter sitting in probably a 5 or 6 inch channel. Why? Probably because they didn't have a 6-inch filter at time, but as soon as that system starts up, you know that filter is going to vibrate, slam into the back part of the wall, and just shake the dirt right out of the filter. So it only becomes a self-cleaning filter in some regards. Are the gaskets and sealing mechanisms intact and functioning? So in this case, you look at the filter on the right as closed cell gasketing, dual stripped. It looks really, really good. The only problem doesn't come to the door or to the end of the tracking. So there's still a very large gap there where the air can completely bypass that filter and reduce the performance of the system. In the bottom left here, you got just damaged filters. Again, this is a commercial application, but you see 5 or 6 pleats in a row, probably water damage on the cardboard. They start to collapse, and that hole is only going to get bigger over time unless it gets replaced immediately. So now, good thing with this, handyman's best friend, duct tape actually works pretty good in sealing filters. You can seal if you're putting 2 or more filters in a row, that putting duct tape on them for 2 or 3 months that they're in operation is a really good idea. The furnaces on the right here, again, sometimes they just have a piece of sheet metal that gets either thrown away or put aside because it's hard to slip on. And duct tape, again, works really good to provide a door and a seal on that filter. Very inexpensive, but very productive too. So we got to ask the question, is all the air going through the filter? So on the left-hand side here, you got a 1-inch filter in a 6-inch track, and then you got the right size filter maybe in the second one, where the filter actually is filling the whole space, and it's not going to flop and bang and knock a whole bunch of dirt off the filter. The founder of BGE, if it doesn't fit, it doesn't filter. That was his favorite saying, and it's very true. The air does not want to go through a filter and will take the path of least resistance, just like in water. And the more efficient the filter, the more the air will want to bypass. As we increase in efficiency, the pressure drop on those filters also go up, and the air is going to try to bypass it more and more. And fit becomes as important as efficiency. So just having a MERV 13 filter and throwing it into any system doesn't necessarily give you a MERV 13 filter system efficiency. This was some research done by Dr. Siegel at University of Texas. And in this case, you look at just with some minor gaps, 1.25 inches, you could have a MERV 14 filter. And again, I'm just going to throw out some numbers. Say it's $75 a filter. I don't know if that's Canadian or US, but for 75 with 1.25 inch bypass, you reduce that $75 filter to a MERV 6, which might cost $5 or $6, just by not sealing that filter in place and not allowing all the air to go through the filter. Extremely important. And if you're in the industry, you've probably seen lots of these where maybe the filter just was the wrong size, or maybe the ductwork wasn't sized correctly, or it's not square anymore, and we have to bend filters into the tracking, or the tracking hits a gas line and you can't service the filter anyway. So again, we got to do better as an industry, and I'm not just talking about the filtration industry, and I'm talking about the sheet metal people and the furnace installers. We need more physical space and better physical space, especially during design and installation. And there usually is lots of room at that point. So as an inspection list, we should be going through this on a regular basis. Is the filter bank and the housing rigid? Is it solid? Are the channels clean? Gaskets and sealing mechanisms intact and functioning? Are they actually working? Do we have the right type and quantity of fasteners if it's locked into place? Look for wear and tear in the filters. If there is, need to be replaced immediately. The filter is not going to get better if it has a hole or slash in it. Are all potential leaks between plenum and frame sealed? So even a flashlight test, if you can actually get upstream and downstream of the filter, is great. Or even you can see dirt bypass a filter where it leaves it on a coil or the ductwork too. So the bottom line is all the air going through the filter. That's the big question you have to ask, is all the air going through the filter? So if you read the residential guideline, it will be broken up into a system approach, and I'm not going to get too in-depth on the equipment because, again, this is not my area of expertise, but we looked at, what are the majority of systems found in residential properties. And we broke it down to furnaces, unitary air conditioners, fan coil units, heat pumps, and room air conditioners, mini splits, that type of thing. So in all of these, we recommend a MERV 11 filter. In most of them right now, it's very difficult to even get a MERV 11 filter into to what we're given as the filter apparatus or the hardware. We don't really have a lot of physical room to do that. Going forward, there's no reason why it can't be added. But right now, it's hard to retrofit these systems from maybe a MERV 6 to a MERV 8. The additional air cleaning options, we looked at gas phase. So gas phase is going to be similar looking to a mechanical filter, but again, designed to remove odors and gases from spaces. We get a lot of calls. As mentioned earlier, we're going through probably the worst fire season I've ever seen in Western Canada. We've had fire days that are poor air quality days in May, June, July, and August, and it looks like we'll have them again in September. Wouldn't it be nice if you had a system where you could put in a mechanical filter and a gas phase filter in the same filter housing or filter box? I don't know of too many systems that are designed for that today, but going forward, why not? You should be able to accommodate that, especially at installation. UVGI, ultraviolet germicidal irradiation, is a great complement to air filtration, mechanical air filtration, and can be used in conjunction with mechanical air filtration. And is usually, or a lot of cases, put into the duct or right into a room. So again, a very good option if you're worried about irradiating live virus, bacteria, mold, that type of thing. Electronic air cleaners, at one time they were extremely popular, very high efficient, can replace the mechanical filter, and the downside is possible creation of ozone, and the maintenance on it is quite laborious. So you end up in a lot of cases not getting service as often as they should be, and the efficiency on the product diminishes as the plates start to get dirty and they don't transfer the electricity as evenly. And room air purifiers. I can't even imagine, maybe someone has the number, but how many were sold during the pandemic, but I'm sure it's in the hundreds and hundreds of thousands. And everyone, even not in the industry, were making them. So you can get all kinds of different looking units, and take your pick, but it's really buyer beware what you're getting, how much air is it moving, and how efficient is the cleanliness on it. So, but again, a good complement to air filtration, gaseous filtration. And if you have someone that's compromised, especially in your house, putting one into a bedroom makes all kinds of good sense. So I'm going to talk a little bit about filter maintenance and disposals and disposal. One thing I've had or given talks for the last 3 years, like during COVID, and talking to all kinds of associations, and my usual shtick on service and disposal is that a filter is probably still has viable contamination in it. So what it is, a lot of cases I don't know, but I'm pretty sure if you put a petri dish on a dirty filter, it would grow some ugly looking bugs and what have you. So the importance of handling the product or the spent product with care makes all kinds of good sense. Use the correct PPE, gloves, glasses, definitely a face mask. Remove the product quickly, put it into a bag or box, seal it, and then dispose of it as quickly as you can. Get it out of the area. For future design, and I sort of mentioned a little bit of this, here's what we would like to see going forward. A lot of cases, you can upgrade the systems to a MERV 13 or MERV 15 just because the physical space in the unit is so restricted. But anyway, we're looking at dedicated outside air source supplied directly to the HVAC unit, not just dumped into the basement or the fan room, whatever, but just like a commercial building, bringing air in from the outside and going right through the HVAC system. Filter hardware that will eliminate the chance of air bypassing in the system. If the filter doesn't fit into that system and is not locked into place, you're not going to get the efficiency that you think you are. You might feel comfortable buying a MERV 13, but if you're only getting MERV 8 filter efficiency, you just wasted a whole bunch of money. Sufficient filter system area and depth to accommodate newer filter technologies. When I suggest a higher efficient filter, the first response 99% of the time is that, oh, there's too much pressure drop, I won't be able to get any air through it. Newer technologies allow us to put higher efficiencies in a lot of the same areas without too much of an increase in pressure drop. But my point here is just make the box bigger. Put two filters in side by side. You can do that during construction when you can't do it later on when the unit is contained into a mechanical area. But there are things you can do. Deeper beds, so that you get a better air to cloth ratio, and we slow the air down as it goes through the filter. All this helps to reduce the pressure drop and provides less impact on the fan and motor and the ventilation that you're looking for. Designed for a minimum MERV 13 filter system. In the future, we got to at least start MERV 13, and then we can go from there. But that's where we need to design it. And fans and motors capable of overcoming the increase in resistance with the use of higher efficient filters. And we should be documenting that and sensing. So we should have control features that allows a homeowner to evaluate and monitor service life of a filter and the quality of the air being supplied to the occupied space. They should be able to see when the filter is either starting to be loaded or reaching its final pressure drop and needs to be changed. And also some quality of air on a sensor or a device that will allow them to make an educated decision on when to change it. If you're in the industry and you have technicians, you should get them certified. National Air Filtration Association has an excellent certification program. As I mentioned, we got, I think, 18 guys that have their certification. There's companies with way more than that too. And it's a really good program and well worth checking out. The NAFA org website or get a hold of a NAFA member and they'll help you go through the steps. How would I like to see this guideline used? Well, I think the filtration industry to read it and feel confident with the guidance. And if you don't, reach out to us and we'll see what we can do. Use it as a reference to promote air filtration, validation, as well as the NAFA programs, CAFS and NCT. Download the free guideline from the NAFA website and provide your customers with a customized copy with your company's logo on it. We're happy to distribute it free and, like I say, with your logo on it, get it out in as many hands as you can. And for the building and HVAC industry to read it and feel that they got some valuable advice and practical direction from it that they can actually use. And lastly, I would like this document, as well as the other guidelines and all NAFA publications, to be used and acknowledged as the reference and a guidance in all things filtration related. And my final thoughts, and I give this one every time I'm talking commercially also, is that, and again, it's, pandemic driven in some regards, but an unprecedented amount of money is being set aside for upgrading equipment, schools especially, commercial buildings, and even residential properties. And as an industry, we have a unique opportunity to participate in this growth, but also a responsibility to ensure the filter component is designed and installed correctly and will withstand any future extraordinary events. And extraordinary events could be the wildfire smoke. Wouldn't it have been nice to be able to upgrade your filter from a MERV 6 to a MERV 13 and maybe put in a carbon filter, downstream of it? Most systems, 99.9% of them aren't capable of doing that. It's either one or the other. But during design, you can design it for that. And it'd be a heck of a shame if we replaced old equipment with just shiny newer versions without thought for increased ventilation and filtration capacity. So we need to take this in, during the design phase. There's my contact information. Again, we have some pretty good questions, so I'm going to hopefully address the ones that are outside the webinar. But if you have any pictures or any comments, by all means, please feel free to share them directly with me. I'd be happy to comment on them. So thanks again for your time.
Great job, Kevin. I always learn something. I always think about what's going down in my basement right now here, thinking, oh, yep, I did that. Yep, I did that. Oh, I'm not doing that. So I always pick up something new.
I know a guy in your area.
All right. Just send him through. Speaking of the guidelines, I just want to, maybe I can win a Clean Air Award. I really can't. But I just wanted to connect the dots for folks that are in the commercial or run or are a service provider in a non-residential building. And so NAFA has this thing called the Clean Air Award. And the simplest terms is if you go through these guidelines and you kind of go through this criteria, there's this actually a form that we have, and you go through and you kind of check all the boxes. Like you go from, boy, what is it, Kevin? Go from a MERV 8 to a MERV 13, or there's, you go through these improvements and gasketing filters and things like that. And if you go through the improvements, then what you can do is you can get your customer, a facility manager or their building, like a library, a school district, a hospital, a continuing care facility, right? They can win a clean air award. And so it's amazing, because then of course the facility gets to show off that they have clean air. And of course, thinking about people working from home, like, don't you want to be the office building that wants, obviously you want your employees to come back to work, right? And work inside. Well, another feather in your cap is that you've won a clean air award and make them feel comfortable in doing that as well. And one final thought, I know we talked, in fact, you might want to go back and we might have mentioned this, Kevin, when we did the commercial office buildings guideline, is that, and I think Joe Allen, who is the Harvard professor, talked about this, where you can actually, as a building owner, charge more rent to your tenants because you have these higher guidelines or these higher standards, and adherence in your commercial office building. So just, hey, if you like money, something to take a look at. So anyway, so a plug for the Clean Air Awards. We're actually going to give away our Clean Air Awards at the annual conference, and take a look at that, and reach out to us if you have any more questions about working with building a stronger relationship with your customers. Okay, so Kevin, and there's a few questions. Some of these were submitted ahead of time. I know a few have come through, and so we'll try to get through as many as well. We might do some of these rapid fire because I know you touched on these, but maybe let's make sure we answer their question if you feel like if you feel like maybe we touched on it, but maybe put a button on it. Okay, sure. So our first question is HVAC, or are HVAC equipment manufacturers working on making furnaces that can handle pressure drops of filters higher than MERV 14?
As far as I know, I mean, some of them say they sell HEPA filters, but you would need quite a larger fan than you would with a MERV 6 or MERV 13. But I did talk to a contractor today about this, and they basically say that the motors that they have, whether they're constant torqued or variable speed drives, that the variable speed drive will handle filter pressure drops into the MERV 15 and MERV 16 without enlarging that too much. Like he was saying, a half horsepower would do that, but it has to be a variable speed. So and again, if you can get a MERV 14 system in it without impacting the motor too much, that's a heck of an improvement in your air quality.
So a related question here: is it a good idea to use HEPA filters at standard HVAC systems, increasing face filtration area to reduce pressure drop? There might be a couple words missing in there, but
and again, in a perfect world, and you saw by that chart that I had, one of the slides about the penetration, the HEPA filter is like, that's the Cadillac. In most residential application, it's probably is overkill. If you can get a MERV 11, MERV 13, 14, 15, or 16, it's doing pretty darn good. You're doing a heck of a job in there. So as much as I like to say, yeah, HEPA filters for everybody, it's not really realistic in today's market.
So we'll connect the dots here for another semi-related question here. So why MERV 11 as the new recommendation as opposed to MERV 13?
Oh, good question. I think it came down when we were debating this, like, because there's, the majority of the units are already in use. So if we're looking at the total inventory of residential air handling or HVAC systems, probably 95% of them, are are in use and how many can go from a MERV 6 to a MERV 13. MERV 11 to me was a compromise. So we compromised at MERV 11. We're asking that any future design start at least MERV 13. So I think, an upgrade of this document, which will happen the next couple of years, will probably go to MERV 13 because that will start to reflect the interest in the marketplace and the thing that if new systems are all designed at MERV 13, there'll be more and more MERV 13 filter systems in HVAC residential properties. Long-winded, but
yeah. Well, and maybe just again, as a layman like myself, like we're all our own technicians for the most part, right? So I think, like you said, and ask yourself the question: is all air going through the filter, right? And so,
right, yeah,
does it make sense to have a MERV 13, right?
If the air is bypassing, they turn that MERV 13 back into a MERV 8. You haven't accomplished anything. But a MERV 11, we feel that most systems could handle that without doing any modifications to their system. So
again, work your way up.
Yeah. Yeah.
Okay. So how about so you touched on UVC, that it can be done. How about should it be done, right? Is adding UVC homes to homes with forced air recommended?
I think if you're concerned about especially virus, it's a great complement to mechanical filtration. Doesn't impact the mechanical filtration per se, and it just adds another layer of defense to for your air quality. So yes, I think it is a good idea.
Okay, excellent. Okay, let's talk about, let's see, there's the difference in the selection of filter stages for residential air filtration for different locations.
Yeah, and again, I'm not sure exactly where they're coming from, but I would say right now, like again, I'm going to use Western Canada as an example. I think like 2 weeks ago, we had 7,000 fires in Western Canada, like Northwest Territories, British Columbia, Alberta. It would be really nice if we started the design for that particulate. And again, it's made up of a lot of that PM 2.5 micron size and smaller, and MERV 6 just doesn't cut it. So if I was designing here and I was going to buy a furnace, I'd be looking at starting at MERV 13. So if that's where they're coming from with that question, although I think MERV 13 can work anywhere, you really need it where the air quality is many times of the year is just unhealthy. And you think of other parts of the world where the pollution is really high, you would want that also. And even in North America, there's areas where, some cities are more polluted than others. So putting a higher efficient filter in there just makes all kinds of good sense.
Here's a one. Who decides the size of my residential furnace filter? The manufacturer? The installer?
I like that too. So furnace, if you see, you go to the store and you buy one, it has an opening that goes into the furnace chamber, but the contractor who buys that unit then has his sheet metal guy attach it to the ductwork in your house. So at that point, he can do whatever he wants. And I know the last time I changed my furnace, I got them to put a longer vertical run in so I could go from which at that time originally was a 1-inch filter track to a 2-inch, and now I have a 6-inch in there. But they had to change the ductwork a little bit. So it's really up to them. And as I was saying earlier too, there's nothing to stop them from making it, maybe that opening going into the furnace is say 20-inch by 20-inch. There's nothing that says you can't build a box that's 40-inch by 40-inch if you have the physical space there, and make it 8-10 inches deep. And the more you do that, the more filter area, the more filters you have in there, the reduced pressure drop and the higher performance you get out of that filter system. But again, it's how well the filters are locked into that apparatus.
Okay. All right. So Ryan says, a mechanical engineer told me that duct sizing and fan type are the most important in determining what filter one can use in the system. especially considering throwaways versus plates? How could one assess if their duct sizing is adequate?
Duct sizing, and what was the other part of that? I didn't.
Said that the duct sizing and fan type are the most important. This is what a mechanical engineer said.
I still duct sizing and
Duct
what?
sizing told me that he said that the duct sizing and the fan type are the most important in determining what
Oh, the fan
filter
type. Yeah.
one can use in their system.
Again, if you look historically at the box, that does make a difference. Like, I wouldn't put a HEPA filter in there thinking I get the best filter possibly. If I don't get any air, I sort of defeated the purpose. So, but in saying that, if you can make a bigger opening for the filter and lower the air to cloth ratio across the filter, I have a lot more filter face area. You're going to lower pressure drop, and you're not going to affect the ventilation into the space or anything. And the pressure drop will be a much flatter curve than, putting something in that's really dense in a very confined space or a smaller space. So as a filter guys, we need more room. That's the big thing. Depth, width, height, whatever. The more we can get, the more we can do for you.
Okay, so there's a couple questions that seem to be related here. So one is, I'll ask two questions in a row here, and I think they've got some dots connected here. So is it just splitting hairs between MERV 10 and MERV 11 pleat? The other question is, what's your true assessment of using MERV 10 versus MERV 8 pleated filter?
Again, it all comes back to what I'm trying to stop. If I look at that one slide with the MERV 6, the MERV 11, the MERV 13, and the HEPA filter, what am I willing to allow to penetrate my occupied space? If I want to reduce it to near zero, I'm going with a HEPA filter if I actually could. If I want to get it into, very healthy position, a MERV 13, 14, or 15, and you start getting into 14, 15, 16, that's hospital grade filtration in a lot of regards. Very, very high efficient. The MERV 6 and the MERV 8, they just don't do a good enough job on that size particle that we're trying to stop. So anytime you can go up without affecting the ventilation, why wouldn't you?
Got it. Okay, good. We're good. You good on time, Kevin? We got a few more questions.
Yeah.
I think we can get through these here. Got about 8 minutes left or so. Let's rock and roll. Okay, so we question about ceiling-based air filters. At what MERV rating do you start to gain pressure drop? Are there any studies that show the correlations between the two?
You're talking like a ceiling module, or?
He just said for ceiling air filters.
At CEILING or
CEILING.
okay, yeah. Well, mostly of those cases they would just recirculate back in the space, so they're not going to affect the pressure drop at all, and just add to the overall cleanliness of a physical space. So if you visualize, whether a house, I'm in a meeting room right now that's probably 30 by 20. If I had a ceiling module in here, it would just recirculate the air in that space. So what was getting in here would just help clean that and reduce the particulate load in this space. And as we added people, would do that much better job. So it supplements the mechanical filtration at the HVAC unit. So I'm all for it if it works, but it shouldn't have any effect on pressure drop or, other than in the ceiling unit itself. In most cases, they're self-contained with a fan or a blower on it anyway. So.
Awesome. Okay. So there was a gentleman that I accidentally dismissed this question. To say live, but actually I was going to type back to you. There was a gentleman that was asking, there's some disagreement, maybe some controversy on pressure drop and HEPA filters, and whether there is or isn't. I would say, I don't know if you want to address that or not, Kevin, but we are actually in November. We are going to have a IAQ myths webinar. You should attend that. In fact, you should also submit a myth when we ask you questions, the myths they want to talk about. I think our panelists would love to talk about that. So I don't know, Kevin, if you want to save it for that, maybe you should be on our panel when we talk about IAQ myths.
Yeah, I'll address that one now too, because it's, I mean, the HEPA filter is very dense. So like if you're trying to push air through a HEPA filter with a half horsepower motor, you're probably going to have a hard time, especially if it's sealed properly and the air is going through it. But and again, as I mentioned earlier, it's probably overkill. Like I don't know if I never had any commercial customers have a HEPA filter, even consider that. At best, they might have gone up to MERV 15, maybe. So having it residentially would be really tough. You'd have to design your system with that in mind as you install the unit. Can it be done? I'm sure it can, but you would probably need a very expensive housing and expensive filters and probably expensive, fan and blower to be able to push the air through it. But then you'd have one heck of a system. So
For sure, for sure. Well, that person's either shaking their head and or maybe agreeing, maybe shaking their head. And that's where I would say this is what NAFA is all about. So if you disagree with any of that or any of this, that's why you should be here, right? This is, not everybody agrees. Not every member agrees with one another. This is all science-based organization and our education. And, if you'd love to talk about this stuff, you should get yourself to Nashville or in the spring at Tech Seminar. Be part of the conversation for sure. In the spring, we'll be in Irving, Texas, which is just outside Dallas. All right. That's a good one.
absolutely.
All right. Okay. So Michelle asks can you talk about the importance of filtering gas with a carbon activated filter? You talked about carbon filter there in a second here. When is this necessary? What is the typical pressure drop with a carbon
Again,
filter?
they can be relatively high also, because usually it's not one or the other. You still, in most cases, need a mechanical filter, so you'd still need that MERV 11 and then a carbon filter or an embedded type media. And the two back to back would be some substantial pressure drop. You would use them, again, when in our wildfire smoke seasons that we're getting in Western Canada, we get tremendous amount of calls because of the odor. People smell the odor and the smoke smell and want to get rid of it. That's when you would use a filter of that range. But you still want to stop the particulate. The gas phase filter in most cases aren't effective on the particulate. So if you only have room for one, you have to make that decision. Is it the odor I'm worried about, or is it the particulate? And in most cases, I like to say the odor is a nuisance, the particulate's a killer.
Excellent. Okay, so looks like we have one more question. Last call for questions. If you want to submit one here, what we do with our last minute and a half. And so I don't know how much you want to talk about this, Kevin, here, because I know UVC is not necessarily your specialty, but maybe we want to pass this off to another one and another thing. But just talking about once the person wants you to expand on UVC intensity necessary to have an impact on airborne viruses.
And again, it isn't really my area of expertise, but every system is unique. So you have to look at getting somebody in there that has the knowledge and especially the design and the application, because just putting a single bulb into a large ductwork and having the air fly by it at 500 feet per minute, it's just not going to work. It has to be designed just like mechanical filters are designed for, to protect a coil or to be in front of a coil. The UVC system has to be designed that way also.
Very good. Yeah, as I understand, in my understanding is there's a certain amount of exposure time, right? And so that's important there.
Yeah. And is it designed for killing air kill, or is it a surface kill, like on a coil or that type of thing too? So, or you can have in-room systems. So it really depends on what you're trying to accomplish. But in saying that, there's a lot of engineering involved, and you need to talk to someone that's really, really knowledgeable on it, or it's a bit like the room air purifier. It's buyer beware, and yeah, you might not be happy with the results that you get.
Awesome. Well, excellent. Please hang on. I think we got run out of time here. Please hang on till after the webinar because we want your input. So please take the survey that we're going to pop up here. So, Kevin, do you have any final thoughts? Words?
Oh, again, just thanks for attending, and look forward to any comments anybody has. And by all means, send me pictures, or if you do have a comment, or you want to say something positive or negatively, there's my email address.
We're not afraid, right? We'll hear you out. We'll talk. Let's talk it over. And if it's in Nashville, come over, come have a beverage of your choice, and we're all friends here. So anyway. All right. So there's a gentleman that asks, please email Kevin about that email or that one specifically. He had some dimensions that he had questions and a recommendation based on that, but that might be difficult to do verbally. So email Kevin on that one as well.
All right.
So okay. So I think that is it. So thanks so much for your time. I am going to get to editing as soon as I close this out. You take the survey, please. I'll get to editing and I'll send this out to everybody within the day or so, and you'll get a copy of the guideline. You'll get a copy of this recording and of Kevin's slides. If you have any questions, you can reach out to us at NAFA at nafahq.org, and you can also just find us at nafahq.org. So thanks so much. Thanks, Kevin. I appreciate it as always.
You're welcome. Thanks, everybody.
See you in a couple weeks. Take care.
Bye.